and welcome to Math Made Simple. My name is Jay Double. If you have not already subscribed to my channel, please consider doing so that you will receive notifications whenever I upload new contents. Today, we will be looking at the applications of function into real-life situation. We will see how function can be used to model simple and complex real-life situations into a simple mathematical expression that can be easily manipulated when the variables in the situation change. Without much ado, let's begin right now. Number 1. A high school is planning a field trip to one of the popular zoos in the country. They are taking a commercial bus which holds 50 persons. It will cost $20 for parking, and a ticket to enter the zoo, including accommodation, is $12 per student. So we want to model this problem using a concept of function. So in order to model this problem, what we want to do is first identify the independent and the dependent variables. Okay. So that is what you will always want to do to identify the independent and the dependent variables of that identical problem. So the two variables that will interplay are the number of students and the cost of the trip. And the number of students will actually determine the cost of the trip. So we say the number of students is the independent variable and the cost of the trip will be the dependent variable. So we say the independent variable n is the number of students making the trip. The dependent variable is c of n, which is the function of n, the total cost involved. All right, so after identifying the dependent and the independent variable, the next thing we want to do is to model the equation for the situation. Now, in modeling the equation, since we are to find the cost of the trip, we say the cost of the trip is actually the cost of the parking and the cost for the entrance to the zoo. The cost of the entrance to the zoo is $12 per student. So the number of students multiplied by 12 will give us the cost of entrance into the zoo. So in order to determine the total cost of the trip, will just be 12 multiplied by n plus the $20 for parking. So in equation form, that would be c of n equals 12n plus 20. So if you see here clearly, the cost of the trip is a function of the number of students making a trip. Okay, so after modeling the equation, what you will want to do is to find the domain and the range, since this is a function. And the problem says here they are taking a commercial bus which holds 50 students, meaning for this identical problem, we will have a maximum 50 students making a trip. So the number of students n will actually be between 0 and 50 because there's a possibility that no student made a trip. That is a possibility, and there is a possibility that all 50 of them made a trip. So those are the two extreme limits. So we will say the domain equals 0 less than or equals to n less than or equals to 50, and we say n is a whole number. That is the domain. Now, in order to determine the range, what we do is we take the two extreme limits and use it into our function, then we will know the limits of the range. So our function is c of n equals 12n plus 20. Then we use 0 into the function, which will be c of 0 equals 12 times 0 plus 20, which is just 20. So there's a possibility that no students went for the trip, but actually we made a trip. The bus was available and the trip was still made. And in that case, we will have no expenditure to make at the entrance of the zoo. But one expenditure that we will have to make is for the parking, because once the trip is made, it means we have to do the parking. Okay. And the other extreme will be C of 50, which is 12 times 50 plus 20. 12 times 50 is 600 plus 20 is $620. So it means if we have 50 students making a trip, we'll be paying a total of $620. So the limit of our range will actually be 20 and 620. So it means our range would therefore be 20 less than or equals to C of n less than or equals to 620. Okay, number 2 says, Kona works at the Ministry of Education. Her hourly pay rate is $1.50. She is required to work for 160 hours in a month. No overtime allowed. She also receives a total allowance of $30 monthly in addition to her salary. So this is another situation that we can use function to model. Okay, so like I said in our previous problem, in order to model this situation, we need to identify the independent and the dependent variables. So looking at this problem has to do with Conan's work, and she is required to work for a certain number of hours, and based upon that, she will receive her monthly salary. So the number of hours represents the independent variable, and the salary she receives at the end of the month is the dependent variable. So in modeling this problem, we have the independent variable, which is H, the number of hours worked in a month, and the dependent variable is S of H, her gross salary at the end of the month. Okay, so the next thing has to do with us modeling the equation for this problem. Her gross salary will actually come from the monthly allowance plus the hourly rate multiplied by the number of hours that she will work. So we will have the equation as S of H equals 1.5 H plus 30. The 1.5 is the hourly rate and the H is the number of hours. So that's the equation that will model this problem. And then what we want to do is also determine the domain and the range. And the problem says she is required to work for 160 hours. So meaning she cannot go above 160 hours as per the agreement, and there is no overtime. So the possibility that she did not work at all exists. She may have gone to work, but she did not complete even a single hour. That's a possibility. So we say the domain is 0 less than or equals to H less than or equals to 160. So we say the domain is H is a set of all real number. 0 is less than or equal to H less than or equals to 160. And the range. So we will use our extreme limits of the domain into our function to determine the limit of the range. So we will use 0 in our function. S of 0 equals 1.5 times 0 plus 30, which is just 30. And we also have S of 160, which is 1.5 times 160 plus 30, 240 plus 30, which is 270. So she will be expecting to make now more than $270 at the end of the month, provided she put in all of the time. Now let's look at problem number 3. Election is around and Peter decides to start a business by printing party caps and selling them for $2.50. The printing machine costs $500 and the material for each cap costs 50 cents. He is interested in calculating his profit. To get started, he orders 2,000 caps. So the two things of interest here is the profit and the total sale, because from the total sale you can be able to determine the profit that he has for this business. All right, so we will say that the independent variable N is the number of caps sold, and the dependent variable is P of N, which is the profit from the sale of N caps. So profit is total sale minus total expenditure. He needs to know how much he put into the business and how much sale he made. So in modeling our equation, we say that the total sale is the cost of each of the caps multiplied by the number of caps that he sold will give us the total sale. And the total expenditure will be the number of caps multiplied by the material cost of those caps and plus the cost of the machine. Okay, so our equation now will be P of N, which is the profit, equals the total sale, which is $2 times the number of caps sold minus the total expenditure, which is $500 plus 50 cents times the number of caps that was bought. Okay, so here we can simplify this equation. So that would be P of N. We break up this parenthesis, so you have minus 500 minus 0.5 N. So you subtract the 0.5 from 2, you will have 1.5 minus 500. So P of N becomes 1.5 N minus 500. So this is the equation that will model our problem. Then we need to determine the domain and the range. So let's see the restriction here. The restriction is that he orders 2,000 caps. So the 2,000 cap is our restriction. So 0 to 2,000 caps is the number of caps that he will either sell or not. So it means the domain becomes the number of caps to be sold, which is 0 less than or equals to N less than or equals to 2,000, where N is a whole number. And we use the two extreme limits into our function to determine the limits of the range. So we use 0 in there. You have 0 times 1.5 minus 500, which would be minus 500, which is a loss, of course. If he did not sell any cap, then you will have a loss because he bought a machine for $500. So you will have that loss. And then we use the 2,000 caps into the equation. You have 1.5 times 2,000 minus 500 is 3,000 minus 500, 2,500 bucks. That becomes the upper limit. So we say our range would be minus 500 less than or equals to P of N less than or equals to 2,500. Problem 4. Mr. Tanu Molian charges $50 upfront plus $45 for each day he works for the local government. He plans to use the full amount he will earn during the month to add to the $200 he has to buy blocks for his building construction project. Blocks are sold at $1.50 per unit. He's wondering how many blocks he will be able to buy. So the first thing is he will work and earn his salary. That's the first thing. That's the first part of this problem. Then the next part of it is using that of his salary to buy a number of blocks. So this is a composite function problem. All right, so we go ahead to model this situation. We say the independent variable for the first part is D, which is the number of days that he will work. And the dependent variable is a P of D, that is the pay that he received from the work that he will be doing. The pay is the $50 upfront plus the $45 multiplied by the number of days, because he charges $45 per day in addition to the upfront $50. So then the equation for that first part becomes P of D equals 45D plus 50. That will give us the total pay that he's expected to make. Then the pay he will receive will determine the number of blocks he buys. So the dependent variable in the first part becomes the independent variable in the second part. All right. So therefore, we conclude that this situation presents a composite function. Okay, like we said in our previous explanation. So the independent variable now for part 2 is P of D. Then the dependent variable will of course be B of P of D, which is the number of blocks he will buy. So then our equation now for modeling the second part will be B of P of D, which is the number of blocks, will be the total pay plus the $200 that he has divided by the cost of each block, which is 1.5. So that will become now P or B of P of D equals P of D plus 200 divided by 1.5. So which is just be B of P of D equals P of D divided by 1.5 plus 133.33. That is 200 divided by 1.5 is 133.33.